Good afternoon. So this is going to be a brief demonstration of how to convert binary numbers to Denary. Okay. This is similar to the coursework task that you've been issued. So apologies, I'm going to try and do this. I'm using a keyboard and mouse, so I'm not sure how well this will work, but we'll see what happens. So, say for example you've been given a binary number. In this case, I'll use 1 0 1 1 0 0 1 1. For the purpose of this, I will be using an 8-digit binary number. If you have a value that is less than 8 digits, that's absolutely fine, and we can still work around it. But first thing you are always going to put up is your placeholder values. So colour for that. So our placeholder values up at the top of the screen will be 1, 28, 64, 32, 16, 8, 4, 2, and 1. Sometimes written as just U for units. So if you've got an 8-digit binary number, these are the placeholders you need. If it's less than 8 digits, obviously you don't need to write all 8 down, but you always start writing the 1, 2, 4 and so on, working from the right hand side out to the left. If you're ever unsure, pop down the 8 at National 4, National 5 level. You will not be given more than an 8-digit binary number. So what we can then do is we can take our binary value and simply slot it underneath. So 1, 0, 1, 1, 0, 0, 1, 1. And we're halfway there. So now that we've got our values, our binary values, and our placeholders, what this essentially does is this binary 1 symbolises that there is the value above, this 1 represents the value above. So if we want to find out what 1 0 11 0 0 1 1 is in our Denary number system, like we would normally use ourselves, all we do is we take all of the values that have a 1 above them and pop them down below. So we're going to have 128 plus nothing under 64 plus 32, as there's a 1 underneath, plus 16, and we have nothing under 8, nothing under 4, then we add our 2, and we add our 1. So, if you want to write it in a nice wee sum format, you can do as we have here. So, next we are adding them up. So for argument's sake, bear with me a second. So 3, 19, 41, 51, so 179. So we can see 1 0 1 1 0 0 1 1 is equal to 179. Okay, that's our first example. So what I will now do is move over to the eraser, make this nice and big, and I'll get rid of these. I'll leave my placeholders in place because we'll now do another example. But this time I'm going to use a smaller non-8-digit number. So what we'd like to find out, make sure that's on pen so I don't rub stuff out. We are going to start with 1 0 1 1 0. As you can see, this is just a 5-digit number. I've already got my 8 values, so we're filling it in from the right hand side. So 0 1 1 0 1, and you can just leave it there if you like, or if you're wanting to make sure you've got a note of absolutely everything that you would need, we don't have a value for these, so we can just pop a 0 underneath. So once again, if we do 1, 0, 1, 1, 0, this is going to equal 16, and then we've got the 4 with the 1 underneath, so plus 4 plus 2. We carry this on, 16 plus 4 is 20, plus 2, so 22. Okay, and that's essentially all we really have for converting these over into from binary to denary. And with that, I will leave this little demonstration there. Thank you. If you've got any questions, again, I will be in a Teams meeting during every scheduled class, so if you would like any support or you're not totally sure what we've covered here today, you can just let me know and I will jump into the team and I'll do a wee demonstration for you or answer any questions that you have.